This is example 4 on sketching rational functions. For this function, there is no factoring to be done in the numerator or denominator, so let's go straight to doing all of the steps we need to do to find the information we need. Step 1 is find the y-intercept. To find the y-intercept, we evaluate the function for x equal to 0. Anywhere there's an x, you're going to plug in a 0. And here you have that this is equal to -1 over 0, which is undefined. That means there is no y-intercept. For step 2, find the zeros or x-intercepts. That means you take the numerator and you equal it to 0. So my numerator is x minus 1 equals 0. That means x is equal to 1. That is my 0. For step number 3, we're going to find the vertical asymptote. And that means take the denominator and equal it to 0. So x squared is equal to 0. That means that x is equal to 0 for my vertical asymptote. This means that the y-axis is your vertical asymptote. For step 4, horizontal asymptote, we said that we need to look at the degree in the numerator and the degree in the denominator. If the degree in the numerator is less than the degree in the denominator, which it is, then the horizontal asymptote is y equal to 0, which means the x-axis is the horizontal asymptote. And step number 5 is where we draw a number line and do our sign analysis. Okay, here's my number line. I am going to plot on my number line. Sorry about that. I'm going to plot. What information do I plot on there? Remember, we're always going to plot the zeros and the vertical asymptotes, and that's all we're going to plot on this number line for step 5. So I have a 0 at x equal to 1. I'm going to say, here's x equal to 1 right here. Here's 1. And I also have a vertical asymptote at x equal to 0. So here's a wall at x equals 0. Okay? These two critical values divide my number line into 3 intervals, from -infinity all the way to that wall at 0, from 0 to 1, and from 1 to positive infinity. So I have 3 regions that I have to test. Let's do the first region, which is from -infinity to 0, and I'm going to choose -1. And what do we do with the -1? We're going to come up here and we're going to say, if I plug in -1 for x and I subtract 1, will this result be positive or negative? It will be negative. If I plug in a -1 for x here, will this result be positive or negative? Remember that any negative number that's squared will always be positive. So now I have negative divided by positive. It's negative. So I know that in this region, my graph will be below the x-axis. Okay? Let's do 0 to 1. For 0 to 1, I'm going to choose 0.5. So when I plug in 0.5 and I take away 1 from 0.5, will this be negative or positive? It's going to be negative. When I plug in 0.5 and square it, this is going to be positive. Negative over positive, negative. That means that it's going to be below the x-axis. And now we're going to do from 1 to infinity. Let's choose 10. Okay, so if I plug in 10 and I take away 1, the result will be positive. If I plug in 10 and I square it, it will also be positive. So positive divided by positive, positive. I'm done with my sign analysis. Okay? Now we're going to start graphing. Let's put all of the information we found on our graph. Let's start with our y-intercept. There is no y-intercept, so I'm not going to plot anything on my graph. Let's do zeros. 1, 0, x equal to 1. My vertical asymptote is x equal to 0, which is the y-axis. That means there's a wall right here. Your y-axis is the wall. Your horizontal asymptote is y equal to 0, which is your x-axis. That's your other wall. Okay, I have all the information on this graph. So let's see what happens. I know that from negative infinity all the way to that first wall, which is at 0, my graph is below the x-axis, so it's down here. Now notice I have a wall horizontally and vertically. That means that this graph will come from very close to the asymptote, like this. It separates from the asymptote, and it's going to approach the other wall and get very, 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 very close to it. And there is your graph below the x-axis. Now I'm between 0 and 1, which is also below the x-axis. So I'm in between the back of this wall, vertical wall, and 1. In between these two little spaces here, my graph is below the x-axis, so it's negative. That means that this graph is coming from very close to the wall. Remember that the graphs approach these walls. And as it comes up, it's going to hit that 0. Remember, the 0 attracts the graph. It pulls the graph towards itself. It hits the 0, and what happens after 1? After 1, the graph will be above the x-axis. So after I hit 1, now I will be above the x-axis. Now, where do I go? Am I going to go all the way up this way? Am I going to remain very close to this asymptote? Well, actually, since this is an asymptote here, I will remain very close to the asymptote and get very, very close, but never, well, sometimes we do cross it. We did cross it here. It will be closer and closer and closer to the asymptote. And there's this graph for this function. Let's do the WZ grapher graph and see if it looks like this one. Here's the graph for WZ grapher. Notice that the graph from negative infinity all the way to my y-axis, which is that first wall, it is very close to the horizontal asymptote, then it separates, and then it gets very close to the y-axis. And for that second part of the graph, which is behind the wall, behind the y-axis, behind the vertical asymptote, notice how close it is to the vertical asymptote. Then it starts separating. It will cross at x equal to 1. You see where it says x equal to 1 right here? That's the 0. It will cross and go above the x-axis after 1, but will approach the horizontal asymptote. So this is very close to what we sketched. Looks pretty good. There it is. Okay, I'll see you in the next example.